I don't need I'm not doing anything.
Just to let you know, we're gonna ask students. I have students set up in teams.
No means no.
Up here, they have little whiteboard markers, and these are actually whiteboard students.
Oh,
So he has a marker if he wants to test it out, and then we're calling I mean, he, do you want to jump on your phone, or no, you're okay? Just okay. Mom's right there.
we could just sit. We're almost always wrong. No, that's really. They also have this time.
Nice! A lot better. A lot better. Good job. Whether you originally got it right or wrong. Whether you originally got it right or wrong. Can I have somebody up, come on up and show me their work, please? Michelle, do you want to go up? Thank you. Can you make sure to write a little big so that we can see from the back?
What you like?
From both sides, which would then equal 6 being x. And then we would plug 6 into y equals 2x plus 1. That equals being 6. Y equals 13.
All right, Michelle, so let me ask you a couple of questions. First, where did this come from, this equation here?
Oh, I put x plus 7 equals 2x plus 1.
And what is the name of that method?
Substitution.
All right, nice. And so down in this step over here, once you got to this point here, what was the next step for you?
I plugged in the x variable, which is 6, into the equation y equals 2x plus 1.
Okay, so would it have mattered which equation you used?
No.
Probably not at that point. But let's say I really want to know whether you're right or wrong. I want you to check for me. Which equation would you use next?
You would use y equals x plus 7.
Can you show me how that looks like?
I would plug in y equals 6 plus 7, which would then equal y equals 13. For x, I would plug in 6. I would plug in 2. Oh. Y equals 2, 6 plus 1, which would then equal.
So can you just take a step to the don't erase. I want to look at it. Okay, so can anybody tell me, is this the way we want to check our work? How can she improve her method? Valerie?
So she was trying to check it, but we know what y is, so we would plug in the value of y into where she's trying to check it.
Is this the area you're talking about, Valerie?
No, that one.
This where? This one up here? Okay, so instead of writing down y, what should she, oh, this one right here? What should she write?
So then it would equal 13 equals plus 2 times 6 equals 12 plus 1 equals 13. So then
Is this true? Does 13 equal 13?
yeah.
So is Michelle right? Yes. Okay, one more thing though. How do I want my answer? Michelle, do I want you to draw a big fat arrow pointing to y and pointing to x and saying, here it is, that's my answer.
You draw
What does this represent?
Coordinates for 2 lines intersect.
There you go. Okay. Next one. Good job. Thank you, Michelle.
I knew that. Right.
y equals 3.
Fine. Yeah. Okay.
Oh, y equals x.
Plug it in.
You would plug in, no, what's the next step? So y equals 4x, or y plus 4x.
Keep your work on your tables, please. Keep your work on your tables. Don't erase them. I'll be right there.
If you have a difficult, that doesn't really give you.
I mean, it could.
Come straight back. Are you going to the office? You get it at the office? Okay.
Wait, what did you do? What did you do? What are you doing? It was not enough. Sure. Why did it was not?
Each other. Okay. Quick question. Quick question. How many solutions does this system have?
Zero. None. Wait.
I'm getting a couple of different answers. Okay, so let me ask you again. This time I would like you to raise your hand and tell me. Okay, how many solutions does this system have? Raise your hand. Jesselyn? One. How do you know, Jesselyn?
Because every system has only one point of intersection.
All right. Jesselyn, were you able to find that point? Okay. Why don't you go ahead and show us? While she's working on her way up there, let me ask the rest of the class, how can you tell whether a system has no solutions?
When all the answers are incorrect.
Go ahead, Devin. Ah, interesting. And why would an equation with Same slope, but different y-intercept, two different equations. Why would they not have a solution? They're going at the same incline. What's the word that we use for that? A little louder. They would be parallel. They would be parallel, right? Okay. Listen, the reason I ask you to keep your work on your whiteboard is because if you erase it, can you compare it to Jesselyn's work?
No.
Tomorrow when you work on those problems, okay, am I going to need to see your work?
Maybe.
Yes. Jesselyn, can you walk us through the process here?
For this system, I also use substitution. So I substitute this equation in here. So I did 3x plus x equals 8. And then we would add the right variable. So it equals 4x equals 8. And then divided by 4 on both sides, which equals x equals 6.
Nice. Okay, so what was this method that you used here? That's substitution. Okay, and the next step?
And then you plug it in. So you get y equals 3 times 2. And then y equals 6.
And so was this solution that you wrote down, was it up here on the board?
No, so there's no right answer.
Oh, there you go. Okay, so just keep in mind that on here, it doesn't necessarily mean that there was no solution. It just means that the solution wasn't up there. Okay, thank you, Jesselyn. Very good job. Okay. Next one.